Resume recording. Okay. So again, what is a chemical equation? Describes a chemical change. And there are two parts to an equation. There is the reactant side, and then what comes after the arrow we call the product side. Okay. And this arrow in the middle means a reaction is taking place. It's telling you which way this reaction is occurring. Because technically, if you build something, you can also break it down. Hey, Phoenix, would you mind turning off that music for me, please? Thank you. All right, so what we can see here is, in this case, we have silver and hydrosulfuric acid making silver sulfate and hydrogen gas. So what's happening is this is the reactants, these things are combining. This is the product side, this is what's being made. You could flip this around. It depends on whether energy is coming in or energy is going out. So that's one thing we're not seeing here, but just understand chemical reactions can usually be reversed depending on the situation. All right, so like I said, reactants are chemicals that you start with before the reaction. They're usually written on the left side. And the products are what are on the right side of the equation, what's made by that. So we have reactants on the left side and products on the right side. Now, there are two different sets of numbers. One we've been dealing a lot with, and we already know what that is, and then one I just barely showed you just a moment ago that we're going to talk about more in depth today. But those two numbers are called subscripts and coefficients. Subscripts are the little numbers after a molecule. So when we talked about water, H2O, that 2 is a subscript. Now there's technically a subscript on the oxygen. Remember, chemists are lazy, so if it's 1, they just don't write a number. So this is really H2O1. Okay, if you don't see a number, it's understood to be a 1. If it's more than 1, the number has to be included. So in this case, like I said, 2 atoms of hydrogen, and there's 1 atom of oxygen in H2O. The other number that I just barely showed you a minute ago is called the coefficient. Okay, the coefficient shows how many molecules there are of a particular chemical. So if I write 3H2O, what that really means is that there are 3 different water molecules here. So this is a multiplier. So if I want to know how many hydrogens there are in this, I take 3 times 2, and that tells me there are 6 hydrogens. If I want to know how many oxygens there are, I take the 3 times the 1, and that means that there are 3 oxygens. So this right here is representing 9 different atoms being joined together to form 3 water molecules. So a balanced equation is going to show you subscripts and coefficients being used together to make sure basically they're the same number of atoms on each side. We're basically doing accounting, okay? So here's a chemical reaction, and what we see here is we're taking hydrogen gas plus oxygen gas, and we're forming water from it. Now, when we were talking about the warm-up, we noticed that there was this leftover oxygen, and it had to go somewhere. And what this is showing us is what we did to make the oxygen happy is we added in more hydrogen gas. So we have 2 sets of hydrogen gas coming in. Those are little green circles coming from the top and from the bottom. And then we have 1 molecule, because there's a coefficient of 1 here, right? If there's no number, it's a 1. So 1 molecule of oxygen, and what they form is 2 separate individual water molecules, 2 H2Os. Now, why do we have to do this? Well, we do this in order to obey another law, the law of conservation of mass or matter. Now, you guys we've already talked a lot about the law of conservation of energy, right? That's that energy cannot be created or destroyed, only stored or transformed, right? Law of conservation of matter is very, very similar. It says in a chemical reaction, matter is neither created nor destroyed. That means that we can't just disappear that extra oxygen because we didn't want to use it, and we can't just magically make two hydrogens appear out of thin air because we needed it to make that oxygen happy. It's got to come from somewhere. It's got to go somewhere. So basically, in other words, the number and type of atoms going into a reaction must be the same as the number and type of atoms coming out of a reaction. So therefore, an equation obeys the law of conservation of matter if it is balanced. Because if it's balanced, they're the same numbers, kinds, and types of atoms on both sides of the equation. So that's what we're pushing to do today. I'll fall asleep trying to give this lecture. Okay, so again, matter is neither created nor destroyed. It's got to come from somewhere. It's got to go somewhere. So let's take a look at some chemical reactions. All right, here we have methane gas, and we're going to burn it. And when we burn that methane gas, we are going to release carbon dioxide and water. Okay, so what we're going to do is we're going to attempt to determine, is this balanced or not? So what I do is I look at the two different sides of the equation. I'm going to draw on this one, okay? So here's my line, right? On the left side, I've got my reactants. On the right side, I've got my products. And so what I need to do now is I need to figure out, do these two sides match? Are they equal? Well, if I look over here, I've got one carbon. If I look over here, I've got one carbon. So yes, the carbons are balanced, one in, one out. I look here, I've got 4 hydrogens. I look on this side, I only see 2 hydrogens. So that should already tell me, whoop, this is not balanced. I put in 4, only 2 came out. So something's not right here. And then I could also look at my oxygen. I've got 1 oxygen on the left side, and I have 3 total oxygens on the right side. 2 from the carbon dioxide, 1 in the water, for a total of 3. So I can tell that this is not a balanced equation. So what I have to do is I have to adjust things so that it eventually becomes balanced. Now, I'm always going to start with my biggest one. So in this case, I've got 4 hydrogens over here, but only 2 being used over here. So what we could do is we could take and we could put a 2 out in front of this H2O. Now all of a sudden, I have 2 times 2, which is 4 hydrogens, and 2 times 1, which is 2 oxygens. So I've got 4 hydrogens on this side, 4 hydrogens on the reactant side. Now my hydrogens are balanced. But what's left? Well, my oxygens are not balanced. I only put 2 in, but there are 2 and now 4 on the product side. So what do I have to do? Well, I have to double the amount of oxygen I put in. So what I'm going to do is I'm going to put a 2 here. And now what that shows me is I've got 4 oxygens on this side and 4 oxygens on that side. And so it is now balanced. Okay, and we can look at the little drawings here. 4 red circles, 1, 2, 3, 4 red circles. Those are our oxygens. 4 green hydrogens, 4 green hydrogens, 1 gray carbon, 1 gray carbon. This equation is now balanced. Now, when we balance chemical equations, there are some rules that we have to follow, okay? And let's get into those now. Number 1, we have to obey the law of conservation of matter. Matter cannot be created or destroyed. That's rule number 1. That's why we're balancing equations. Rule number 2, subscripts cannot be added, removed, or changed. Let me show you an example of that. Let's go back to the whiteboard, okay? And let's look back at this. So let's rewind this a little bit. Back until, okay. Oops. Okay. So now look at this, right? This is the water formula that we started with. Hydrogen gas plus oxygen gas gives us water. What this is saying, this rule, is we cannot change the subscripts. Remember, there's only 1 oxygen right here, right? So I can't change this subscript to be a 1 and just eliminate an oxygen, because oxygens do not come in single pairs. I cannot change how atoms bond just because I want to. So you cannot change the subscripts ever. Do not do that. Once the subscripts are there, they are permanent. You don't get to decide how an atom bonds just because it makes you happy. I also can't just change the subscripts of my hydrogen to equal 4 or whatever I need. So I cannot change the little letters because I cannot change how atoms bond together. All right, back to the notes. And third, well, if I can't change the subscripts, what can I change? I can change the coefficients. This is like how many scoops. How many scoops of hydrogen do I put in? How many scoops of oxygen? Well, I need 2 scoops of hydrogen gas, 1 scoop of oxygen gas, and that gives me 2 scoops of water, right? I can change the big numbers out in front, which represent how many molecules there are. Another rule about coefficients is they can only go in front of the formula, not in the middle. So what do I mean there? Well, what I mean is, let me go back to whiteboard. I cannot put a coefficient in the middle. So I can't go like this. I can't put H22O. That doesn't work, okay? The 2 has to go out in front, and it applies to the whole chemical, okay, the whole molecule. So I can't put the 2 there. I have to put the 2 out in front, and again, that's going to go to that whole molecule. That's how we got there. All right, that's really the only rules that you have to follow. So let me give you some tips to help you with how to balance chemical equations. Guys, people struggle with this just because it's odd. It's not something that we do every day, but I promise you, if you follow my steps, it makes it very, very, very simple, okay? Number 1, try balancing the biggest formulas first and save any free elements, as those are elements by themselves, for the end. Because what's going to happen is if you get the big things balanced and there's just one thing that's left over at the end that's not balanced, we can change that one that's by itself without changing the whole rest of the equation. If I try and balance the small stuff first and I leave the biggest one for the end, when I change to accommodate the bigger molecule, I'm going to end up having to change all the smaller ones again anyway. So start with the biggest ones first. And then there's no one way to balance an equation. If you guys have ever been in math and ever heard of a guess and check, you guys ever heard of that, where you kind of come up with an answer and then you go back and see if that's the right answer? This is kind of a guess and check thing. Sometimes you're going to change one coefficient and that's going to make one thing balance, but it's going to throw another thing out of whack. And so you're going to have to go back on the other side and change that one to match. And then you're going to jump back and forth. So sometimes it just takes a little, playing around with the numbers until they match up and you get just the right combination. So let's do some practices. I want you guys to do this the same exact way every single time you balance a chemical equation. Let me say that again and louder. Do all the steps that I'm about to show you each time you try and balance a chemical equation. This is going to solve you problems in the long run. So here's a chemical equation. The first thing I need to do is I need to ask myself, is this balanced? Well, I see 2 nitrogens on the reactant side, 1 nitrogen on the positive or on the product side, obviously not balanced. 2 hydrogens on the reactant side, 3 hydrogens on the product side, again, not balanced. So what are you going to do first? We're going to make a table. So let's make a table. And I'll do it right underneath to make it simple. All right, and please write this down on your paper. We got reactants, we got products. Out to the left side, we list each atom individually, each unique atom individually. So we have nitrogen, and we have hydrogen. And that's it. There's no other elements in here. I only see N's and H's, that's it. Now, once I have my table set up, I'm going to count my atoms. On the reactant side, how many nitrogens are there? Well, it's N2, so that tells me that there are 2 nitrogens. On the product side, how many nitrogens are there? Well, I just see an N with no number, so I know that means that there is 1 nitrogen. Then I go back to the reactant side. How many hydrogens are there on the reactant side? Well, that's H2, so there are 2. And then I go to the product side, I see H3, so that means that there are 3. So now I've done my count, and again, it proves to me that this is not a balanced equation. So I'm going to start with my biggest one first. Can I ever use less than 2 nitrogens? No. So there's no way for me to only use 1. So what I'm going to do first is I'm going to balance my nitrogens. If I put in 2, that means 2 have to come out. So I'm going to put a 2 there. Now that changes this whole thing right here. So now, how many nitrogens do I have on my reactant side? I cross this first number out. I don't erase it. I cross it out, and then I put the updated number there. 2 times 1 gives me 2. But this also changed the amount of hydrogen that I have here. So now I have 2 times 3, which gives me a total of 6 hydrogens. So now I check to see if things are balanced. My nitrogen on the left side is at 2. My nitrogen on the right side is at 2. Nitrogens are balanced. Now I look at my hydrogens. I've got 2 going in, but I've got 6 coming out. So now I can see that this is not balanced. But look, hydrogen is here by itself. So I can just change the amount of hydrogen that I put in, and this should balance itself out. So the question we have to ask ourselves is, what times 2 gives us 6? 3, exactly. So I'm going to put a 3 here, and now 3 times 2 gives me 6 hydrogens. So now 2 and 2, 6 and 6, this is a happy and very balanced chemical equation. So what did I do? Well, step 1, I made my table. Step 2, I counted up my atoms. And then I started changing the coefficients to balance it. That's how you solve these. Okay? Let's take a look at another one. All right. Now, in this case, I've got 3 different atoms. I've got potassium, I've got chlorine, and I've got oxygen. And I'm just letting this thing break down into potassium chloride and oxygen. So let's see what this is going to look like. So the first thing I do is I make my table. So make your table, reactant side, product side, and then I'm going to list all 3 separately. So the first one I have is K, which is potassium. The second one I have is Cl, which is chlorine. And the last one I have is O for oxygen. All right, so now I have my table set up. So now I count my atoms. On the reactant side, I have 1 potassium. On the product side, I have 1 potassium. On the reactant side, I have 2 chlorines. On the product side, oh, sorry, no one caught that. That's a mistake. Let me back that up. Eraser, please. Sorry, there's no number there, so that means that there is 1 chlorine, rather. 1. And on the product side, there's also no number there, so that means that there's 1. And then I get to my oxygens. On the reactant side, I see a 3 next to that, so that tells me there are 3 oxygens. But on the product side, oh, there's our problem. There's only 2. So even though the first 2 atoms are balanced, because oxygen's not balanced, this whole equation is not balanced. So now we've done our count. Now we need to change things to make them balanced. Now here's the issue. I can only multiply by whole numbers. So what's the issue here? Well, on the reactant side, how many oxygens do I have? I've got 3 oxygens. On the product side, I have 2. Can I multiply any number by 2 to get 3? Any whole number? No. So my odd and even here create a problem. So what I'm going to do when I see something like this is, because I know I've got an odd number here, what's the easiest way to get an odd number even? You double it. So let's put a 2 out here and see what happens. Now this changes the whole side, not just the oxygen, right? So now I got to go through and recount all my atoms on this side. So 2 times 1 now gives me 2 potassiums. 2 times 1 chlorine gives me 2 chlorines. And 2 times 3 oxygens gives me 6 oxygens. Now I do my check. 2 and 1, 2 and 1, 6 and 2. So this is still not balanced. So now I'm going to go back to the other side. If I put in 2 Ks and 2 Cls, how many KCls am I going to need on the reactant side? I'm going to need 2. So let me put a 2 out here. So that changes this one to 2. It also changes this one to 2. But notice this plus, right? That separates it. So this 2 only goes to the KCl. All right, goes no further. So now I do my check. Potassium is balanced, chlorine is balanced, but now my oxygens are not balanced. But look, oxygen is over here by itself. That's why I left it for the end, because now I can just change my oxygen and it doesn't change anything else in my equation. So what times 2 gives me 6? 3. So I'm going to put a 3 here, and that changes this oxygen to 6. So now I've got 2 and 2, 2 and 2, 6 and 6. This is a happy, balanced chemical equation. Any questions on this one? Okay. Let's do one more together, and then I'm going to have you try one on your own. This is a little bit more complex. This is some kind of carbohydrate being broken down into carbon dioxide and water. So let's go ahead. What's the first thing we do? Well, we got to make our table. So let's make our table. So I've got the reactant side, got the product side. Now I list my elements. In this case, I've got carbon, hydrogen, and oxygen. Now I do my count. How many carbons on the reactant side? Don't all shout at once. How many carbons are on the reactant side? 2. How many hydrogens are on the reactant side? 6. And how many oxygens on the reactant side? 2. Now I go over to the product side. How many carbons on the product side? I only see 1 because there's no number there, so there's 1. How many hydrogens? I see 2. And how many total oxygens? Well, I see 2 in the carbon dioxide and 1 on the water, so that's a total of 3 oxygens. So is this balanced? Heck no. 2 and 1, 6 and 2, 2 and 3, nothing is balanced, okay? So like I said, start with your biggest one. In this case, what's the biggest one? Well, it's this one right here. It has 8 atoms in it, right? This is the biggest one. So I have a minimum of 2 carbons here. So how many minimum carbon dioxides am I going to need to make? Well, if I put in 2, I have to make a minimum of 2 carbon dioxides to make that carbon get used. So I'm going to put a 2 there. And now that changes this side. How many carbons do I now have? I'm going to cross the 1 out because now I have 2. Okay. But that also changes the amount of oxygen because now I've got 2 times 2, which is 4. Sorry, you can't see where I'm pointing. 2 times 2, which is the 4, plus my single one over here for a total of 5 oxygens. There are now 5 oxygens on the reactants, or excuse me, on the product side. So now my carbon's balanced, but my hydrogens are definitely not balanced. So I've got 6 going in, So what's the minimum number of water molecules that I can make? 3. So I'm going to put a 3 in here. So now 3 times 2 gives me 6 hydrogens, but this also changes the oxygen, doesn't it? 3 times 1 gives me 3, right? 3 times 1 gives me 3, but I've got my 4 over here. So 4 plus 3 now gives me a total of 7 oxygens. Now look at this. We've done all this hard work. We've got the carbons balanced. We've got the hydrogens balanced. But now we're going to run into a problem. What's not balanced? My oxygens. And on the reactant side, I've got O2. That's an even number, an even multiplier. I cannot make this odd. But over here, I've got 3 times 1, which means I'm always going to get an odd number over here. So this is where I'm stuck. There's no number that I can put in front of here to make 7. I can't put, 3.5. I can't do that. Okay, I have to put a whole number here. So if you ever get stuck like this, where you've got an odd, everything is balanced but one thing, and you can't get it to balance because you've got an even and an odd issue, it means that you have the right ratio. You just need to go one bigger. So what I'm going to do is I'm going to multiply this whole equation. I'm going to double everything. Okay, watch what happens here. I'm going to double everything. So I'm going to put a 2 out in front of CH or C6, excuse me, C2H6. I'm going to leave oxygen blank for a moment. I'm going to change this 2. I'm going to erase it. I'm going to make it a 4 to double it. Sorry, this is much easier when I'm doing this on the board, not in this damn program. All right, and then I'm going to take that 3 and I'm going to double it to a 6. And now once we've done this, let's recount our atoms. So on the reactant side, I've got 2 times 2 carbons. So how many total carbons do I have now? 4. 2 times 6 hydrogens now gives me 12 hydrogens. I'm going to leave oxygen by itself because I didn't change that one. Now let's go to the product side. Now I've got 4 times my 1 carbon, so I have a total of 4 carbons. I'm going to jump down to hydrogen. So I've got 6 times 2, that gives me 12 hydrogens. And now we have to ask ourselves, how many oxygens do we have? Well, if I look over here, 4 times 2 gives me 8. And then 6 times 1 gives me 6. So 8 plus 6 gives me a total of 14. I have 14 total oxygens. So now everything is balanced except the oxygen. My carbons are still balanced, 4 and 4. My hydrogens are still balanced, 12 and 12. What do I need to put in front of this oxygen to give me 14? A 7. Okay, so now I come in, I add that 7, and that changes this to 14. And this is now balanced. There is one more tiny little check that you need to do. Let me pull up the whiteboard again to demonstrate what I mean here. Let me erase some of this. Okay. What I want you to do is tell me, is this balanced? Go ahead and make your table somewhere on your piece of paper, somewhere you have room. Make a table and count up my atoms and tell me, is this equation balanced, yes or no? All right, so what do we think? Is this equation balanced? Okay, Mackenzie, you're saying yes? Okay, good. Phoenix, what do you think? Is it balanced? Peyton, is it balanced?
Yeah.
Okay, I'm hearing yeses all around. So let's do our little chart here and make sure. Got hydrogen, got oxygen, right? My reactants, my products. 4 times 2 gives me 8 hydrogens. 4 times 2 gives me 8 hydrogens. 2 times 2 gives me 4 oxygens. 4 times 1 gives me 4 oxygens. Technically, this is balanced. But what do you notice about all of the coefficients? Sorry, that second circle was awful. What do you notice about all the coefficients? 4, 2, and 4. Is there a common factor there? They're all even, so what can we do? We can reduce it. So a balanced equation is the lowest possible whole number ratio that you can come up with. So technically, yes, this is balanced, but it's not in the lowest possible ratio. So the last check you need to do is say, is there a number I can divide all the coefficients by to reduce it? In this case, I can reduce it by 2, right? So I would change this to 2 to 1 to 2 back to our original equation. Okay, let's go back to PowerPoint. So now let's take that knowledge that we just gained about checking to see if this is in the lowest whole number ratio and apply that to this problem. Is there a number I can divide into 2, 7, 4, and 6? No, because of this odd number right here, 7, right? If this were an 8 and it were balanced, then yes, I would have to divide everything by 2, right? But because this is a 7 and everything else is even numbers, there's no way to take the same number out of all the coefficients. So this is reduced. All right, I would like you to try this one on your own, and then we'll go over this one together. So go ahead and balance this chemical equation. So make your table, count your atoms, change your coefficients, and balance it. For sure. You gonna balance, Phoenix? Huh? I can't hear you. Okay. So what did you get? Just tell me the coefficients. Okay, good. Peyton, did you manage to get this one balanced?
What?
Did you happen to balance this equation? I want you guys to balance this one on your own, and then I want to check your answer. So when you have this balance, let me know what you got. You can just read off the coefficients once you have it balanced.
I got 4 iron and 6 oxygen.
Okay. I like the 4 iron. Oh, I see what you're saying. Tell me the coefficients, not your table. What are the coefficients out in front of each number? So what's in front of the FE?
2.
Well, that would only give you 2. Okay, what's in front of the
and 4, and then I got 3 for oxygen.
So you're telling me put a 2 here. You said a what here?
Oh no, I put a 4 there and then a 3 after that.
Yeah, I'm talking about the coefficients. I need to know the big numbers. So, oops. So you put a 4, and then you said a 3.
Yeah.
And then what over here?
2.
Yeah, there we go. Okay, that's what I was looking for. Okay. So, all right, you guys balance this, okay? So that's good. You're understanding this. So just a couple more things about balancing chemical equations, okay? In addition to balancing them, we need to determine what is happening, all right? What kind of chemical reaction is happening? So there's 3 different types. The first is called synthesis. This is where 2 or more substances combine together. Now look at this big, long equation. I don't care that we understand anything about this equation, except that there's this part, plus this part, plus this part, all coming together to make one thing. You guys see that? So all of these were combined into one molecule. So this is synthesis. Anytime I take 2 or more things and put them together into one thing, that is synthesis. Well, if I can put things together, I can also break them apart, okay? So decomposition is just the opposite here, okay? Decomposition is where you start with one thing that breaks down into multiple parts, at least 2. I'm going to tell you, I don't care too much about this stuff, but it is on the final, so you will need to know these. It's going to be one of these 2. I'm going to show you another one that gets a little more complicated, but if you can tell me whether it's being made or being broken apart, you're good to go. Okay. Now the last option is called a replacement reaction. There's actually a single replacement or it could be a double replacement. In a single replacement, this middle one here, we have one element replacing another. So in the reactant side, we have copper and oxygen together and carbon by itself. What happened was the carbon took the copper's place. Now copper is by itself and the carbon is with the oxygen. You see how they switched partners? So this guy was by itself, now copper is by itself. Oxygen was with something, now oxygen's with the carbon. And a double replacement is like Foursquare, change your partners. So we have rubidium and bromine, silver and chlorine, but then we have silver and bromine and rubidium and chlorine. So they swapped partners there. So single replacement is where one replaces another. Double replacement is where 2 or more get replaced. So like I said, focus mostly on the synthesis and decomposition reactions. Those are going to serve you best. All right, what questions do you guys have about how to balance equations? All right, hearing crickets, so I assume that means that we're starting to get the hang of this. So this is what I would like you to do. Go ahead and turn the page, and I believe you guys should have a practice that looks like this. Let me share the screen. Okay, yes, you guys have this practice? Yes, no, maybe so. Turn the page again, sorry. Skip over the lab for now. We're gonna do that lab tomorrow. Skip over that page. And then on the very back page, you should see this, yes? Yes, no, maybe so? Okay, everyone's real sluggish today. All right, so what I'm gonna want you to do is I would like you to choose, let's do 8 from the top and 2 from the intermediate, okay? 8 from the top, you get to choose which 8 you want to balance. You're going to balance 8 of them, and then 2 from the intermediate level. I didn't give you guys a third page, they get kind of crazy, okay? So 8 different problems from this top section, and 2, actually just do 1. Let's do 8 and 1, because there's 3 options there. Do 8 and do 1 for the intermediate. Does that sound good to everybody? Okay. You do also have an exit ticket, which I don't think I included on paper. So you will have to do that online. That is in the Google Classroom. So if you look here, there's a chemical equations, balancing chemical equations exit ticket right there with the Google form. Okay. So go ahead and again, 8 from the top, 1 from the intermediate, and then answer your exit ticket questions. All right, so at this point, you guys have your practice, and there's not much else for me to go through. If you have questions, I'm going to close this so that it can convert, and then I'll open the Zoom back up. So Peyton, if you have any questions, just go ahead and hop back in. But otherwise, guys, go ahead, finish up your practice, and I will see you in class tomorrow. Okay. What's the issue?
I don't have to be here. I can go look at my house and get my meds, right?
Yeah. I mean, I wouldn't consider it, you don't have to be here because this is still class, right? But if you need to take your medication, you take your medication, Phoenix.
I woke up and talked to my physical therapist
Yeah.
and forgot my meds before I came here, and now I realize I
Okay.
didn't look well.
Okay. So yeah, run home, get your meds,